Hello friends, in this video we'll talk about vitamin C and B1. First we'll talk about vitamin C. So vitamin C itself is a monosaccharide in structure, that is L-ascorbic acid. So what happens? It gets reversibly formed into the dehydro form and then into diketo L-glucuronic acid and on series of steps we have the oxalic acid. So here you are seeing this picture. They are the discoverers of the vitamin C. We have the Haworth and Zent-Georgi. Okay, these are the scientists, great scientists who have discovered it. Now, vitamin C is synthesized from the glucuronic acid pathway or the uronic acid pathway. So, what is the main aim of this pathway? If I would briefly tell you, is the synthesis of the uronic acids. This uronic acid synthesis is required for the formation of the glycosaminoglycans. I told you when I was discussing about glycosaminoglycans also. But anyway, let us see the synthesis of vitamin C. So first step, glucose 6-phosphate, like what we had in HMB shunt pathway. We'll compare. We have phosphoglucomutase. There we have dehydrogenase. So in place of 6, 1 is formed. So glucose 1-phosphate. Then 6-phosphogluconate is formed. So in short, the first step of the pathway is easy. Just compare with the HMP shunt. The enzyme and the product is different. Now glucose 1-phosphate on pyrophosphate. On addition of the pyrophosphate, we have UDP glucose. On dehydrogenase, on glucose, in place of glucose, glucuronate. On glucuronidase enzyme, U and P, UP is removed. We have deglucuronate. Then again on the same enzyme, L-gulonate. Then on dehydration, L-gulonolactone. On oxidase, keto on the second carbon, so 2 keto is added, the rest will be same. And on series of steps, L-ascorbic acid, that is our vitamin C. Now please remember one point I am going to tell you. It may be asked in the Viva. The question which may be asked is, why ascorbic acid is not synthesized in humans? Because there is absence of what enzyme? L-gulonolactone oxidase. Even in guinea pigs also. In guinea pigs, monkeys also, vitamin C is not synthesized because of L-gulonolactone oxidase. Please remember that enzyme, very important. It may be asked in Viva. Okay. What are the functions of vitamin C in brief? We are in the redox reactions, but these are upcoming are the main ones. The biosynthesis of collagen, steroids, peptides, etc. Mainly collagen synthesis. Then the metabolism of heme, the aromatic amino acids and the B9 vitamin. Okay. Then antioxidant, immunity, chronic diseases, etc. Okay. RDA and the sources now. So RDA is 60 to 70 milligrams per day. Sources. Please remember vitamin C. C for citrus fruits. So whatever citrus fruit you take, you will get good amount of vitamin C. And there are some others like pineapple, banana, apple, strawberry. The berries also will be rich in vitamin C. Turnip, potato, cabbage, bell peppers, okay. All these will be rich. Watermelon, we call tarboos in Hindi, right? These are all the, but main sources will be the citrus fruits. Applied aspect, we have the scurvy, that leading to bleeding gums, loose tooth, osteoporosis and delayed wound healing. This scurvy was a disorder of the collagen also, remember. Then hypervitaminosis C, formation of oxalate stones in the kidney. What are the other substances that will form oxalate stones? Tell me your answers in the comment section. The question is, apart from vitamin C, which substances will promote the oxalate stones? Let me know your answers in the comment section. Okay? Right. So now we go up to the vitamin B1. that is the thymine pyrophosphate. No need of drawing these structures, but remember what I'm telling. The rings names are actually the pyrimidine and the thiazole ring linked by the methylene group with the pyrophosphate part. This is the structure. Now the functions, coenzyme. Main role is the coenzyme only, TPP, where we can see in carbohydrates, in amino acids and in heme synthesis. Come on, first step of heme synthesis is TPP only. Even TPP also there in the first step of heme synthesis. In amino acids, we have the branched chain alpha keto acid dehydrogenase for branched chain amino acids. Then neurotransmission. In carbohydrates, you can take one example, transketolase best HMP shunt pathway. And RDA for adults 1 to 1.5 milligrams per day, for children 0.7 to 1.2 milligrams per day. The sources will be bread, cereals, pulses, okay, all this. We have the dry beans, peanuts, rice, eggs, okay, all these. Now hypovitaminosis B1, main deficiency will be the beriberi. 4 types, wet, dry, infantile and cerebral. Cerebral is also called WKS, Wernicke-Korsakoff syndrome. So wet is nothing but cardiovascular, affects the heart. Apart from that, even the head and neck, trunk and the lower limbs. Simply all over the body you will find edema. And dry is neurological. There is nerve damage. That is why it's a neurotransmitter vitamin. And infantile. That is where if the mother's milk has less B1, it leads to breathlessness, sleeplessness, decreased cardiac output and loud cry of the baby. Okay. Cerebral is mainly in the vitamin deficient alcoholics. Okay. Right. So references from where I took the pictures. That brings us to end of the video. So thank you so much. I'll see you in the next video.